Hi, and welcome to 8.1 for College Algebra, Day 1, Sequences and Series. So, a sequence is a number or a set of numbers that follow some rule, usually describes an equation, not necessarily an equation, and they are usually defined by one of two ways: explicitly, which is a specific formula that uses n to find the term, or recursive, that uses the one term to find the next term. Recursive typically needs the previous term. Or explicit, you can sort of jump around. You can jump to any term for explicit. Terms are just numbers in a sequence. An infinite sequence doesn't end, has an infinite number of terms. A finite has ends. So, for example, here, this would be an infinite number, or infinite sequence, because, well, I have 4 terms right here. It has dot, 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 so it would keep going. Here, this is a finite sequence, only has the 4 terms. Write the first 5 terms. So if you're given an equation, you typically can just enter 1, 2, 3, 4, and 5 for these ones because these are explicit. So let's start plugging in values. If I plug in 1, 3 times 1 minus 2, 3 times 1 is 3, minus 2 is 1, and I can plug in 2. 3 times 2 is 6, minus 2 is 4. 3 times 3 is 9, minus 2 is 7. 3 times 4 is 12, minus 2 is 10. 3 times 5 is 15, minus 2 is 13. So I would say 1, 4, 7, 10, and 13 are my first 5 terms. Over here, same idea. 3 plus negative 1 to the power of 1. Negative 1 to the power of 1 is negative 1, plus 3 is 2. E plus negative 1 to the power of 2. Negative 1 squared to be 1, plus 3 is 4. Negative 1 to the power of 3 is negative 1, plus 3 is 2. Negative 1 to the power of 4 is positive 1, plus 3 is 4. Negative 1 to the power of 5 is negative 1, plus 3 is 2. So this would be 2, 4, 2, 4, 2. This is famously called an alternating series because it alternates between 2 numbers forever. So those were explicit. I could jump around and do whatever I wanted. I could just plug values and find any term. If I wanted to find, for example, the 50th term, I could just plug in n equals 50 and do it. However, some are recursive. So you need to have the previous terms to find the next term, aka you have to go in order. The most famous one would be the Fibonacci sequence, 1, 1, 2, 3, 5, 8, 13. The Fibonacci sequence is defined as following. A sub n equals a sub n minus 2 plus a sub n minus 1. A sub n minus 1 is the previous term, and a sub n minus 2 is the term before the previous. So let's think about this. If I were trying to find, the third term, let's say n was 3. Well, then plugging it in for 3 for that n right here, I would get a sub 3 minus 2 plus a sub 3 minus 1. Well, a sub 3 minus 2 turns into a sub 1. A sub 3 minus 1 turns into a sub 2. So in order to find the third term, I would need the first term and the second term. So one thing that recursive terms are always connected with are defined terms. So in this case, because I'm using two previous terms, I have to define two previous terms. So I could do 1 plus 1, giving me 2. So my third term would have to be 2, which it is as we see up here. Then I could find the fourth term by adding the third and second term. 2 plus 1 is 3. To find 5, 3 plus 2 is 5. Then 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 would give us 21, etc. First 5 terms of the recursive sequence. So a sub 1 is 3. I get this k minus 1, so again, that's asking for the previous term. So if I'm trying to find the second term, I'm going to plug 3 directly in for that spot. So I'm going to get 2 times 3 plus 1. 2 times 3 is 6, plus 1 is 7. Now I'm going to plug in 7 to find the next term. So 2 times 7 plus 1. 2 times 7 is 14, plus 1 is 15. Now to find the next term, I have to plug in 15. 2 times 15 is 30, plus 1 is 31. And I'm going to plug in 31. 2 times 31 is 62, plus 1 is 63. Now, it says find the first 5 terms. Don't forget that we started with one term. So my 5 terms would be 3, 7, 15, 31, and 63. Last thing we're going to talk about today are what are called factorials. A factorial is when you're multiplied by every integer before it. So for example, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. It's also found in our calculator right here, math prob 4. So math, right arrow key over to prob and 4. So if I were to find 6, math prob 4, 6 factorial, be 720. Okay, so interestingly enough, if I could type this all in my calculator, so if I wanted to, we could do fraction 8 math prob 4 over 2 math prob 4 6 math prob 4. Now we get 28. However, if you don't have a calculator at home that can do all this, I can cheat a little bit. Recognize that by definition, 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And in the bottom, I have 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. Well, what do you notice is these actually all simplify out. So this whole thing can be broken down into 8 times 7 up top over 2 times 1, or just 2. 8 times 7 is 56. 56 divided by 2 is 28. Now, why is that helpful? Well, this expression here on letter B has variables. So I couldn't just type this in the calculator. The calculator couldn't handle it. Well, how can I do this then? Well, I'm going to go back to these numbers, for example. 8 factorial, we just said, was all those numbers. But instead, I'm going to write it as 8 times 7 times 6, and I'm going to leave that 6 as an exclamation point. Because we agree that from here, this is just 6 all the way down to 1. So I really have 8 times 7 times 6 over 2 and 6, right? These cancel. That's exactly what we just did, except for I just didn't formally write it all out. Why didn't I write it all out? Well, let's recognize what's happening. I go from 8 to 7 to 6, etc. I'm always going down by one value. If you want to think about it, I'm doing 8 times 8 minus 1, 8 minus 2, etc. Well, of course, that we agree there. That's 8 times 7 times 6, etc. Well, if I'm doing this idea in terms of variables, well then if I'm looking at the top over here, this n factorial, the first thing would be n, and then it would be n minus 1 would be next, and I would keep going. Well, again, I'm just going to stop right there because I can just leave this as an exclamation point and keep it going. And in the bottom, I still just have n minus 1 factorial. And I have n minus 1 over n minus 1, so I can cancel both of those out. So this whole thing simplifies down to just n. Again, if you wanted to see that all written out, n times n minus 1 times n minus 2 times n minus 3, etc., over n minus 1, n minus 2, n minus 3, etc. Again, we're getting the same things. So all these are going to cancel out forever, again, leaving you with just that n. Thank you for listening, and I hope you have a wonderful day.